Ohayo gozaimasu. Good morning, everyone. I'm honored to be part of this fantastic event and excited to see so much great momentum behind SDN in Japan. I will be talking about SoftCOM, which is Huawei's vision for the next generation network architecture based on open SDN, network functions virtualization, cloud computing technologies, and innovation. Let's take a look at the bigger picture of carrier networks evolution over the last decade or so. Carrier networks are undergoing major changes, primarily due to the mega trends that are well known. Traffic increase, cloud, mobility, and video. We see the first wave of this evolution focused around convergence. It's about the gradual migration of fixed and mobile networks and services to an all IP basis, mainly motivated by carriers' need to move beyond voice and to start generating new revenue from IP services. But as the data and applications all move to the cloud, the next wave of this evolution is really focused around building flatter networks, reducing the number of layers, and increasing use of optical technologies across the network. And naturally, the next wave of this evolution is really about an increased use of software for the control of these networks, just as the IT and software industries have evolved in the last 10, 15 years, but also trying to leverage the innovations from the virtualization world. So hardware and software separation or virtualization and the centralization of network control. But carrier networks are complex. They have been built over the years, if not decades, using a very diverse range of closed and proprietary devices. And as new services and applications emerged, these have been added on an overlay mode on top of the existing infrastructure. As a result, it is extremely hard to manage these services today, to introduce new services, or to offer abstract interfaces on top of these infrastructure elements for third-party application developers to introduce new services. There are multiple dimensions that add to this complexity. If we look at one dimension, which is just the number of network devices deployed in different parts of the network across the last mile, access, aggregation, metro, and core of the network, and within data centers, you see this diversity that really represents the great challenges that these different network domains offer in terms of building scalable networks. In the fixed broadband and mobile broadband, you have different types of devices with different characteristics. And the aggregation, where data traffic is aggregated, groomed, and pushed into the core of the network, you have a different set of technologies and challenges. And the metro and core, where you have the highest level of capacity, you have a different set of requirements. And finally, within the data centers, where increasingly you have hundreds of thousands of servers and devices to be managed, you have a complete set of different challenges. If you look at the end-to-end networks today in the carrier space, you see that over the years, these devices have been built with a lot of embedded functionality. So if you're an operator, you're faced with a very complex environment where you have devices from many different vendors, devices that do not necessarily talk to each other, and each device has a number of functionalities embedded, integrated in a closed environment. And these functions can be of different types. We see that today, we already have the opportunity to take a great amount of these functionality out of the networks and move them into software and onto a cloud environment. That is the foundation of our SoftCOM vision. And these functionalities can be anything from network functions and applications, such as layer 4, layer 7 functionality, load balancers, firewalls, IDS, IPS, IMS functions, and packet core functions. Or they can be network control functions, routing and switching control across different technologies, copper, circuit, or packet, but also traditional IT applications that you can find in a carrier environment, OSS, BSS, and the walled garden services that operators offer today all can benefit from moving to software and being deployed in the cloud. So carrier networks are undergoing a major transformation towards software, and we, Huawei, want to be a driver in that movement. Once this is all moved to software, instead of deploying these functions on proprietary and closed equipment, we want to give the operator the choice of running this software on their hardware of choice. And of course, today, there is a great opportunity to deploy a lot of these functions on commodity hardware. But we also realize that there will be a transition until everything can be run on x86 or general purpose processors. So for some time still, we will see a need to deploy custom ASIC development for specific requirements in terms of scalability and performance. So in the carrier environment, if you really want to fully benefit from SDN and the promise of network virtualization and software-defined networking, we believe that there are 3 guiding principles that need to be applied. The first one is that your SDN architecture must be open. And again, a great emphasis on the openness of SDN. Otherwise, by trying to implement SDN in a closed and proprietary framework, we would be back to the old paradigm of closed networking, which some vendors might want to push. But we at Huawei are firmly believing that open SDN is the answer to this next generation, to this evolution toward the next generation architectures. But also, these interfaces should be standards, because we want to give the operator the choice of deploying, say, a controller from one vendor of their choice, and maybe the network elements from other vendors. And it's only through standards-based interfaces that such a freedom can be implemented and offered. We consider the Open Networking Foundation as the leading standards development organization for specification of such standard-based interfaces, OpenFlow for southbound interfaces. And we also believe that because of the complexity of carrier networks, there will be different types of controllers for different parts of the network. Again, because different network domains have different requirements in terms of scale, performance, availability, security, and etc. So OpenSDN, standards-based interfaces, and end-to-end implementation of controllers are the foundation of our SDN model. We have created a program called SoftCOM Business Initiatives Zoom In program to help our customers realize the business value of SDN and NFV, and helping them go through a stepwise approach to migrate to this target architecture based on SDN and NFV. We have now been working with about 10 tier 1 operators globally, trying to cover as many network areas as possible to make sure that we understand the requirements that are specific to each domain, trying to maximize the use of the existing infrastructure while implementing open SDN and NFV. And these use cases, as I mentioned, span different network domains, including the mobile broadband, part of the network, the fixed broadband with virtualized residential gateway and virtualized set-top box use cases, as well as the SDN mobile backhaul implementation, but also at the service edge and the mobile core part of the network, GI-LAN service chaining, as well as cloud IMS implementation, but also the well-known use case around data center interconnection for the WAN part of the network. Over the next few slides, I'm going to cover each of these use cases briefly, and I'm happy to answer any questions after my talk. Starting with the first one, SDN-based mobile backhaul use case. This is a solution that we have been working on with China Telecom, one of China's largest operators with about 250 million subscribers. As they are implementing the architecture for the next wave of their LTE rollout, they wanted to know how SDN can help them manage this network more efficiently and more cost-effectively. In mobile backhaul networks today, there are many challenges. Because of the increased use of mobile traffic and mobile data, there is a need to deploy a lot more network devices constantly. Managing these devices is getting increasingly complex. It requires a lot of manual operations, which are error-prone and which are costly in terms of OpEx. But also, there is no way to have a global view of the network to dynamically steer traffic when needed. And all of this, while for many operators, the average revenue per user is flat, if not declining. With SDN, if you have a centralized controller as part of your aggregation network, for example, the first thing is that you can have a global view of all your access devices, for example, the cell site routers and gateways. You can manage and steer the traffic dynamically and as needed, but also you can render these forwarding devices more simple and as a result, cheaper, because you're taking out functionality from these remote devices and move them into a centralized part of your network. But also, you can imagine that network upgrades will become much easier because now everything is in software. So we have developed this joint solution with China Telecom based on our aggregation router, which is called the CX600 device, on top of the ATN 900 cell site routers. Through this work, we have been able to demonstrate that double-digit OpEx and CapEx savings can be achieved by implementing this solution. For the next version of this solution, we are completely separating the centralized controller from that aggregation device, and we will be implementing that on a physically separated standalone platform. The next SoftCOM-based use case is the virtualized residential gateway. Similarly, in the fixed broadband network, there are many challenges today due to the booming demand for traffic and for data consumption, and due to the fact that provisioning services in fixed broadband access networks is very complex because services are tied to network devices, and provisioning services requires typically several touch points. In the case of a residential gateway, if you're a tier 1 operator, you might have tens of millions of these devices to manage. These devices can become faulty. There's a need to return these devices, to exchange them. And as more and more services are introduced in the access part of the network, these devices become more complex, more energy consuming, and harder to manage. By moving out functionality from a great number of these devices into a smaller number of devices into the network, the same benefits can be achieved, as explained in the previous use case. So for this use case, we have implemented a virtualized residential gateway function into an OLT device, which is an optical device that sits in the carrier network that can manage thousands of these end devices on the subscriber side. So this is a live trial right now with Telefonica. And we have done this last year, and we will be working on the next generation of this solution as we speak. So this case is very similar to the virtual set-top box, which presents the same kinds of challenges and opportunities. You can move out a lot of the functionality from existing set-top boxes that sit in subscribers' home and put them in the network and make these set-top boxes much simpler and less expensive. The next SoftCOM biz use case is at the edge or mobile core part of the network. As users consume more and more mobile data, it is becoming more and more difficult to manage the service part of this data consumption. And today, the way mobile networks are built, there is a mobile pipe zone, which is primarily about carrying the bits, and it's about the bearer part of the network. And then there is the service part, where through a chain of interactions between different boxes, user awareness, policy, and service awareness, and value-added services are implemented. These are called service enablers in the GI network of the mobile network. This is a terminology from the 3GPP. So if you look at how the traffic is steered today, each flow goes through a number of devices. And these devices can offer functionalities such as firewall, WAN optimization, video optimization and caching, URL header enrichment, and so on and so forth. Today, everything is serially chained. And as a result, there are single points of failure. There is no way to really leverage a common shared pool of resources across all these different functions. And all of this adds to an overall cost because of increased processing and unnecessary processing of some flows. So we believe that SDN, again, can come to the rescue and make things more flexible and programmable. For example, with SDN, you can imagine that if you had a controller, you would be able to steer traffic from different applications and services differently. If you have HTTP video traffic, you might not want to steer that through all your boxes. You might want to steer it in this way, as it is shown in the light blue path here. Or if you have HTTPS traffic, you might want to steer it in a different way. And you might want to define rules for just default steering of your traffic. And that rule can change tomorrow. Today, all of this, it's near impossible because a lot of these configurations are manual and static. With such an implementation and use of SDN, for typical traffic flows, you can achieve up to 60% TCO cost in your GI LAN network. Staying in the same part of the network, for IMS functionality, we see a great opportunity to virtualize functions and to use a common shared pool of hardware resources to deploy IMS, but also other functionalities that reside in the mobile core part of the network. We have built the Fusion Sphere Cloud OS that allows you to deploy IMS in a virtual way, flexibly, with all the technologies that come from the cloud computing industry, allowing you to deploy this either on third-party hardware, commodity hardware, or on Huawei's infrastructure as a service, carrier grade, with high availability functionality. So we have worked with tier 1 operators for all of these use cases that I'm covering here. We have started this work last year. This is ready for testing, and we are expecting commercial deployment availability next year. Moving a little bit deeper into the network, I'm going to talk a little bit about the well-known use case of data center interconnection, or inter-data center WAN. This is another SoftCOM-based use case that we have worked with China Unicom. China Unicom is building about 200 data centers, and as part of their cloud offerings, they want to be able to offer premium services for their customers to be able to manage this part of inter-data center interactions for their services through self-service portal. So there is a lot that can be said about this use case, and there are many ways to implement this. I'm just going to cover two specific scenarios. The first one is a scenario where you have an enterprise LAN or a mini data center. You have a data center, you have a transport network, so that's your ISP, and you have a data center fabric. It can be a third-party data center, or it can be an ISP-provided data center. So this use case is about how you can achieve end-to-end global view and virtual control of this end-to-end network and offer that as a service to your customer, if you're a transport operator, for example, to monetize your transport network, something that today is virtually impossible for many operators. So imagine that for your enterprise LAN, you have a controller. For your transport network, you have a controller. And for your data center fabric, you have a controller. All of this can be abstracted away and offered to the end user as if he or she owned the network, actually. And this connectivity in purple line below can be shown to that end user, a customer, which can be one of your many customers, again, as if they owned the network, and they could now manage this connectivity as they wish. They can say, I'm a multi-site enterprise. I want this type of SLA and bandwidth requirements between my sites for this time of the day, and I want to apply this SLA for this type of traffic, whether it's a backup, whether it's a cloud bursting, or whatever scenario you might imagine. Again, these are things that with traditional technologies are near impossible to implement. So a client controller can sit on top of the transport operator controller and the data center controller and interact directly with the enterprise network, therefore achieving an end-to-end view and control of the virtual part of the network. And you can expand this model to a scenario where you have more than one transport operator. So, continuing on the paradigm of openness and standardization, I want to talk briefly about an exciting technology that we have been building at Huawei, which is really about the next generation forwarding plane for SDN. If you look at how we have evolved from the traditional way of routing and switching to an SDN-based model, we believe that there is an opportunity to push this model further by generalizing these networking devices even more. Basically, by making these devices completely protocol independent in a way that they would not even know what protocol they're working on or what packets, or how should I say, they should not have any knowledge of the protocol headers and fields and so on. You can imagine a model where a centralized controller can program the forwarding device and tell it to go to bit X and look up the next Y bit and take action Z. And as a result, that networking device can act as a switch one day, as a firewall the next day, and so on. It can be programmed dynamically and flexibly. So this technology can apply everywhere in your network where you have a switching or routing functionality. There are many benefits that can be achieved. We have developed this on a real product, our core router. We have developed this implementing a real use case with source-based routing that I will not have time to cover. I'm happy to answer any questions afterwards. And with that, I would like to summarize my talk by outlining that carrier networks are undergoing a major transformation towards software. We want to be a driver in that evolution. We have developed the SoftCOM vision, which is the next generation carrier network architecture based on open SDN, NFV, as well as cloud computing and IT technologies. We are building solutions with customers, and we are investing in SDN and NFV R&D and innovation. We are very excited about protocol oblivious forwarding and the next generation SDN forwarding plane, and would love to work with other players in the industry, both vendors, academic institutes, as well as operators, of course. And finally, we believe that SoftCOM is an enabler for true IT and telecom convergence. With SoftCOM, we would like to think that our vision is to think big and help operators start small in this evolution towards software. Thank you very much.